welcome to this program Education Online. I am teacher Akana Patrick Omoy, a teacher of physics, and today we are going to look at terms used in lenses under the topic lenses and optical instruments. Now, dear learners, for us to understand these terms, we have to choose one type of lens. Then we see how rays will be refracted from that lens. Then it will help us to understand these terms. Now, we are going to choose the convex lens. Convex lens. Now, this is how a convex lens appears. It is thicker in the middle than at the edges. Then in a convex lens, we shall have a line that will be passing through the lens. So a line passing through the lens, and this line we call it the principal axis. Principal axis. Now, rays of light will always be falling on this lens. So if this is the middle of the lens, now if a ray of light that is close to the principal axis falls on this lens, since we said this lens is a converging lens, which means this ray will be refracted to pass through a point that we shall call it the principal focus. So it will be refracted to pass through the principal focus. Then if we have another ray still which is close also and parallel to the principal axis, this ray after encountering the lens still also pass through the principal focus. It will be refracted through the principal focus. There can be so many rays that are parallel to the principal axis. All will converge to a certain point called the principal focus. So these rays can be so many. It can also be refracted through the principal focus. So this point, we denote it with letter F. That is a point along the principal axis where all rays that are parallel to the principal axis will converge after refraction from the lens. Then the distance between the principal focus and the center of the lens, we denote it with small letter f, which is the focal length. Then the point which is in the center of the lens, we call it O, meaning the optical center. Then the midpoint of the lens, we denote it with letter P, meaning it is the pole of the lens. From this side, the midpoint is here. Then from the other side, the midpoint is that. So dear learners, in our previous lesson, we looked at some of the terms that we use when we are dealing with refraction in lenses, or when we are dealing with lenses, among which one, we looked at the principal axis, where we said principal axis is a line passing through the optical center and the principal focus of the lens. Then the second term that we looked at is pole of the lens, where we define pole of the lens as the point which is at the center of the lens. So when you look at this lens, the center is at this point. So this is what we call the pole of the lens. So dear learners, today we are going to look at other terms used when dealing with lenses, and we call it, we say term number 3, and it is called the principal focus. Principal focus of convex lens. Dear learners, what do we understand by the principal focus of the convex lens? Looking at our ray diagram, we shall find that the point along the principal axis where all rays that are parallel and close to the principal axis converge after refraction. So this point is what we call the principal focus of a convex lens. We are saying it is of a convex lens because there's going to be a difference between the principal focus of a convex lens and the principal focus of a concave lens. Now, what do we understand by the principal focus of the convex lens? We say this is a point. This is a point along the principal axis. Along the principal axis where rays that are close and parallel to the principal axis. Converge this is the point where rays that are close and parallel to the principal axis converge after refraction from the lens. So you can see it is a point along the principal axis where rays that are close and parallel to the principal axis converge after refraction from the lens. I said to converge means to come and meet at one point. That is after it has passed through the lens. And the reason why it changes the direction when it passes through the lens is because the lens has a different optical density from the air. So this ray will be traveling from air to another medium, which is the lens. So it will change its speed. That's why it will be refracted, and it will be refracted to a point which is called the principal focus. Then let's also look at the principal focus of a diverging lens. For principal focus of a diverging lens. Principal focus of a concave or diverging lens. So we are specifying them because there's some difference in the principal focus of a concave lens and of a convex lens. Now, for us to also know where the principal focus of a concave lens lies, we have to also draw a ray diagram. That is for light being refracted through a concave lens. Now, consider a concave lens. Consider this concave lens. Now, if this is our concave lens, so a line that will be passing through this center is what we call the principal axis. Principal axis. Then, at the end of the lens here, at the center, we call it the pole P. Also, this is a pole P. Then a point which is at the center of the lens, we call it the optical center. we denote it with letter O. Now rays of light will be falling on this concave lens. If a ray that is parallel and close to the principal axis meets the lens, we shall find that this ray will be refracted away from the normal direction. It was supposed to travel in this straight line, but we find that it will be refracted away from the normal. So when this ray that is refracted, it will appear like it's coming from a certain point on the principal axis. Also, if we have another ray that is still close and parallel to the principal axis, so this ray, after touching also the concave lens, it will be refracted in that direction. But this direction, it will appear like the ray is coming from a certain point on the principal axis. So there are so many rays that will be falling on it. So this one will also be refracted in that direction. But you'll find that it will appear to be don't know whether it's clear. So it will appear to be coming from a certain point on the principal axis. So this ray will appear to be coming from this point. So if we also have another ray that is still parallel and close to the principal axis, also after touching the lens, it will also be refracted in that direction. But it will appear to be coming from a certain point along the principal axis. So this point where these rays that are incident on the concave lens appear to be coming from is what we call the principal focus of the concave lens. Then the distance between the principal focus and the optical center is called the focal length. So now, after knowing this, then we can now go ahead and define what the principal focus of a concave lens is. Dear learners, the principal focus of a concave lens is a point along the principal axis where rays that are close and parallel to the principal axis appear to diverge from after refraction. So when someone looks at the ray from this point, the ray will appear to be coming from a certain point along the principal axis. So, and that point where the ray appears to be coming from is what we call the principal focus of concave lens. So it refers to the point along the principal axis. The principal axis where rays that are close and parallel to the principal axis, appear to come from after refraction from the lens. So we use the word appear to come from because it is not real that the ray is coming from this point, but it will just appear. It looks like it is coming from this point, but in actual sense, it is not coming from this point. So we shall also come and look at the case where we shall say the principal focus of a concave lens is negative. We shall look at the reason why we say it is negative, because it is not the real principal focus, but it appears like it is the principal focus. So the next term, that is term number 5, is the paraxial rays. Paraxial rays. Dear learners, what do we understand by the word paraxial rays? Now, looking at these rays on both lenses, on the convex lens and concave lens, we shall find that all these rays that fall on the lens, they are parallel and close to the principal axis. So these rays that are parallel and close to the principal axis are what we call the paraxial rays. Rays that are close and parallel to the principal axis. Rays that are close and parallel to the principal axis, which means all these rays that are parallel and close to the principal axis are called the paraxial rays. Dear learners, there are still terms that are very important that we always have to note as we are dealing with lenses. And the next term that we have is the focal length. That is term number 6. Focal length. So we denote it with small letter f. Now, looking at our ray diagram, we shall find that focal length is the distance between the principal focus and the optical center. That is for a concave lens. Then also for a convex lens, we shall also find that the distance still between the optical center and the focal length, and the principal focus is called the focal length. So we can say this is the distance between the principal focus and the optical center and the optical center. And the optical center, we are denoting it with letter O. So looking at this diagram, this distance is what we call the principal focus. Then the next term is called aperture. The next term that we also have to keep in mind as we deal with rays in a lens is called the aperture. Now, dear learners, what do we understand by the term aperture? So aperture, when we look at the mirror, so the width of the mirror, how wide is the mirror? Let's start with the convex. So the width of the mirror, that is, say, from this point to that point, is what we call the aperture. How wide is, the lens, the width of the lens, how wide is the length? What about for the concave? How wide is the length? That is from this point up to that point. So this width is what we call the aperture. So this refers to the width of the lens. So the width of the lens is what we call the aperture. Dear learners, there are still terms that are always very important that we have to know, because we shall always be using this term till the end of the topic. So we have to note them carefully. The next term that we have is center of curvature. That is term number 8, center of curvature. Center of curvature. Now, lenses are always cut from the surface of spherical, are always cut from spherical surfaces. So now, the center of the sphere from which this lens has been cut is what we call the center of curvature. So now, assuming this lens was not cut from the sphere, so the sphere will can appear in this form, like when you project this line. So you find that it forms a sphere. Then the center of this sphere, where the lens has been cut from, is what we call the center of curvature. Like, dear learners, notice if you have this to be your sphere, you can cut a lens from this sphere. Let's cut a concave lens from this sphere. We can cut a portion. If we cut this portion of the length of the sphere, then it will form a concave lens. So when we only cut this portion, we'll form a concave lens. Now from here, the center of this sphere from which this lens has been cut is what is called the center of curvature. Now for this is the optical center, which is this point, which means the center can be at either this point or that point. That is the center of the sphere from which the lens has been cut. And let's define. So center of curvature is the center of the sphere of which the lens forms a part. The center of the sphere of which the lens forms a part, or the center of the sphere from which the lens has been cut, is what we call the center of curvature. Then the next term, that is the last term that we are going to look at as we are dealing with lenses, is called the radius of curvature. The radius of curvature. Radius of curvature. Now, what do we understand by the radius of curvature? As we are always dealing with circular or spherical surfaces, the distance from the center to any other point on that surface is called the radius. So now, as we are dealing with radius of curvature, we also mean the radius of the sphere of which the lens forms a part, or the radius of the sphere from which the lens has been cut. So we say this is the radius of the sphere of which the lens forms a part. the radius of the sphere of which the lens forms a part, or we say the radius of the sphere from which the lens has been cut. Now, dear learners, you can be asked questions. Questions can be in this form. You can be asked, define the following terms. Define the following terms. Questions. Question 1. Define the following terms. The following terms. A. Principal axis. B. Pole of the lens. C. Center of curvature. And many others. So they can ask you to define any of these terms that we have listed down. So when you ask, it is you now to define them. Or D, they can say the principal focus. The principal focus. Focus of a concave lens. Then they can also, question 2 can be, draw a ray diagram and on it indicate the principal focus of a concave lens. Draw a ray diagram and on it indicate the principal focus of a concave lens. So dear learners, when a question is given like this, which means the ray diagram you are going to draw rays that will be incident on a concave lens. And when you draw, which means you have to indicate, what is very important, you indicate the direction of travel of the rays, then how the rays will be refracted from the lens, and you also indicate where is the principal focus, keeping in mind that the principal focus of a concave lens is always not real. It is not real because the rays appear to be coming from that point, but in actual sense the ray that does not come from that point. So these are the questions that you can be asked. Now, dear learners, in the next lesson we shall be looking at ray diagrams and formation of images on the lenses. We shall see the characteristics of the images that will be formed on the two types of lenses, that is the convex and the concave lenses. So we shall also find that the nature of the images will always depend on the position of the object. So dear learners, up to this point I will say thank you for attending the lesson. I hope you enjoyed. I'm teacher Kena Patrick Omoy. Thank you. Bye-bye.